Okay, let's give you guys some more practice. So somehow integrate this. So press pause and have a go. Okay, so to do this, you might be tempted to follow our normal routine. Our normal routine would be to use trigonometric substitution. So our normal routine would be to zoom into this bit here and then create our triangle in such a way that that it will satisfy this. Yes, this method will get you to the right answer, but it's an inefficient way of doing it. Rather than just always blindly use trigonometric substitution, try to keep an eye out on something being the exact derivative of another thing. So for example, if you look at this, this here is the exact derivative of this thing here. So rather than just, the point I'm trying to make is don't always blindly jump into trigonometric substitution. Try to keep an eye out on something being the exact derivative of another thing. So this here is the exact derivative of this bubble here. So whenever you spot that, then use normal substitution. So let this thing here. So rather than using trigonometric substitution all the time, in this case, because this thing here is the exact derivative of this thing here, then use this substitution. Let u be this thing here. So if u equals this thing here, then du equals this thing here, and then divide both sides by 2x. That would so dx now equals this thing here. So rather than just blindly use trigonometric substitution, here you've got a scenario where this thing here is the exact derivative of this. So use our normal substitution rather than trigonometric substitution. So here you've got dx equals this thing here. So put this into the dx, and then put the u into this thing here, and then later this x here would get killed off with this x here. So now if you put this into here, put this into the dx here, it will then give you this. It will then give you this. So now this x will cancel out with this x here. So that will then give you this, and then blah blah blah, integrate it, and it will give you integrate it, and then it will give you this, and then u earlier we said was x squared minus 7. So integrate it, it will then give you this. So this is our final answer. So just to prove to you that trigonometric substitution will still work, I'm now going to show you an inefficient way of doing it. So we were trying to integrate this. So our normal routine would be to blindly create a triangle from this bit here. So create a triangle in so normally when we want to integrate this, our normal routine would be to zoom into this bit and then create a right angle triangle in such a way that this thing here will be satisfied. So if you make the hypotenuse to be x, the adjacent to be √7, then the opposite will be this thing here. So our normal routine would be to zoom into this bit, create our right angle triangle. From this right angle triangle, we can obtain this, and we can also obtain this. So back to this bit here. If you times both sides by, so looking at this, times both sides by √7, it will then give you this. Differentiate both sides. This thing here will then become this. Differentiate the right hand side. That will then give you this. So dx equals this thing here. So we can put this into the dx here, and then from our triangle we can obtain this. So times both sides by √7, that will then give us this thing here will equal this. So we can now put this into this thing here. So put this into this, and then x here, which is this x here, we can then put this into here. Then this whole thing here will then become this, and then tidy this up, and then you've got your tan. So merge this with this here. That will then give you this. Integrate it. It will then give you this. So this here is our answer, but we don't want the answer in terms of we don't want the answer in terms of theta. We want it in terms of x. So revert back to our original diagram. Revert back to our original diagram. Then from this diagram, tan would be this. So tan theta would be this opposite over adjacent. So tan theta is this thing here. So this was our answer here, but we don't want the answer in terms of theta. Now we need to translate this bit here. Well, now we've got that bit. That bit there is this, so we can put this into here. So this thing here will then become this, and this here is the same answer as what we had before. Okay, so both methods work, but it's just trigonometric. In this case, is an inefficient way of doing it. So whenever you want to integrate something, try to keep an eye out on something being the exact derivative of another thing. Well, anyway, here I've shown you two methods. Both will lead to this. So this is your final answer. Okay.